So in today's case study video, we are going to see about one of the case study as sleeping barber problem. The same scenario we have seen in the last case study, that is dynamic process problem. Both belongs to process synchronization. Actually, we already discussed about the definition of process synchronization. What is actually process synchronization is? It is actually a task of coordinating the execution of all the process in such a way that no two processes can access the shared data or resources. So in today's case study, we are going to see about sleeping barber. Arishiti, can you explain what is actually we are doing in process synchronization with the data of this problem?
So here's about this. So first of all, for the name itself, we can conclude really simple meaning from it. So a sleeping barber, which means the barber is asleep. So in this, we are actually making the barber as the CPU and the chairs and the customers who will be waiting in the chairs as the process. So first of all, let us take the barber shop. Let us consider this box to be a barber shop and let us consider B as the barber. Now since there are no customers here, the barber tends to sleep. Now let us assume this shop contains n number of seats for the customers to wait. And here for an example, I have took n as the number 3. So there are 3 chairs. So now a customer 1 enters the barber shop and takes the seat 1. Now what does the barber do is that he wakes from the sleep and he cuts the hair of the first customer. Then simultaneously 2 more customers enter the barber shop and what they do is they wait in the other 2 chairs, that is C2 and C3. And what will they do is that they will be waiting until the barber completes the cutting of hair of the preceding customers. And after the barber completes cutting his hair off, the customer will be leaving the barber shop and the next customer who is going to be in the queue will enter and takes this unoccupied seat which is being left by the first customer. And if there are 2 more customers that are going to enter in this barber shop and there are no more seats available, right? So what they do is that the barber tells these customers to wait until for a period of time until he finishes his work with these 3 customers and asks them to come after a certain period of time or asks them to go to another barber shop for cutting their hair. So this can be understood by using this algorithm. So first of all, we will be starting the algorithm and the barber is sleeping. Now a customer arrives and the barber cuts the hair of the waiting customer. And what happens is if there are no more customers, the barber goes to sleep again. And if it is the time to close of the shop, the barber goes home. This is the simple algorithm. And in this problem, we will be facing few challenges, which are resource management. In this problem, we have to manage 2 resources, that is chair and the barber. As I said previously, the chair can be compared with the number of process, and the barber can be compared with the CPU. So resource management is one of the challenge, and then the synchronization of process becomes the second challenge, and then the customer handling becomes the third challenge. As I said before, the customer can be compared with the process. So the process handling becomes the third challenge. Now the method to handle these challenges will be discussed by Harshit.
Now may I use the board here? Sure.
So as Harshit gave a clear idea of the problem regarding to the OS subject, I will explain what are the synchronization mechanisms that will be taking place regarding this. So first one is semaphores. As we have seen in OS, we know that semaphores are the integer variables. So these are the integer variables assigned among the multiple processes. So here the semaphores are assigned to the chairs where the number of chairs are denoted by the semaphores. The second thing is that mutate stop. The mutate stop is explained as only at one time one process can take place. So how does this apply to this? That is, a customer can be engaged to the barber only one person at a time. No multiple
conditional waiting is clearly explained by the process like only if there are 3 customers on the way and if there are 4 chairs empty, one can enter through that and they can wait. But if there are 4 chairs completely occupied, then the 5th customer cannot come and he has to understand that he has to leave the place and he has to come next time or after some time. Then the 4th concept is that barber's actions. So he will be sleeping according to the problem scenario. But when a customer comes, he has to do the haircutting. But if there are no customers, he will be sleeping. So these are the synchronization mechanisms. So now I will be explaining about the simple flow chart with regarding to the OS. So now let's see. Generally we have assumed that the barber is doing his job. So let's start the process. So generally he is sleeping. So what he does is he is waiting for a customer. So we can see that the customers are arriving. So if once the customers arrive, he has to cut the hair. If the no customers are arriving, automatically he will be sleeping. He will be taking rest. Next thing is that if the customers are waiting and he has to cut the hair, then as we have discussed earlier, synchronization mechanisms apply. Then the fourth thing is that when a closing time arrives, he has to go. This is the scenario. So finally, by concluding, as Harishruti explained in terms of the operating system, I would like to conclude in the way that there is a problem or shortage in the resource management and synchronization in OS. So how do we overcome this? Is we have to give a good solution, like when these can take place to avoid the process at the same multiple processes at the same time. And one more thing we have to understand is that no 2 or multiple processes can take place at a time, and it enters the critical section, that is only one process can enter. This will be a good solution.